everyone, my name is Óbuda and I would like to show you my official unofficial solution for the network statics and topics. Now it's the 8th topic about the Datalink Layer, which is a dream topic. The main functions of the Datalink Layer, how does it improve the services of the first layer? So the main functions is quite easy because the Datalink Layer receives packets and packages them into frames from the network layer and receives bits and packages them into frames and forwards it to the upper layer. It also controls the access to the medium and it prepares the medium that data will be transmitted. These are the main functions. So how does it improve the service of the first layer? It's quite easy that there is the transmitter who is host A and there is a receiver who is host B. So if host A will send a signal, the host B, who is the destination, for example, will do at the data link layer an error detection. So that's how it improves. Here you can tell the exact process about the error detection that I already told you in a previous topic, so please go back to there because I don't want to tell everything again. And basically that's all, and yeah, the upper and lower interface of the second layer I already told now that what they are doing, because the data link layer has two sublayers. The LLC is the upper one, which is the logical layer, and the MAC layer is the lower one, which is the physical layer. So basically the LLC is the connection between the network layer and the data link layer, because these are handled by softwarely. So and the LLC does the encapsulation and de-encapsulation and the error detection. Meanwhile, the MAC layer will control the access to the medium and prepares the medium that the data will be transmitted. The structure of the PDU is quite easy. Of course, we have the data at the middle. It has a trailer, which stands for error detection. It has a network transport header, a network header, and the start of the frame. And the synchronization is the start of the frame, which is the preamble, if I know its correct name, because when there will be a transmission on the channel, then the start of the frame, the preamble, will be sent to another device that, hey, there will be a transmission, so be prepared. So this is how the transmission will be prepared, and this is the synchronization, because that does it. Addressing scheme of the second layer, the structure of the physical address examples. It is quite easy that we are talking about layer 2 data link layer, so we are talking about switches. Switches, these are called nodes. So the layer 2 interconnecting or connects nodes together, because within switches we have cables which connects switches together. So we are talking about switches. Switches don't have routing tables like the layer 3 routers, but they have the MAC table or CAM table, and call it however you want. And it's important that because they don't have this routing table always, like the routers, they using the MAC addresses in order to transmit data to their destination. So here, of course, you can tell the process how the switches are learning. If you connect the switch to a network, then the switch's MAC table by default is empty. If it will receive a frame from another device, then it will store the interface on which it was received and its MAC address. Therefore, if next time something will came and that will be the destination, it can simply send a unicast message. But because by default it's the back table is empty, it will flood out on all ports except on the port in which it received the frame. So this is how it works. It has a 5-minute time limit, so it stores a MAC address in the table for 5 minutes. After it will be erased because of course it has a limited number of resources. And if it receives a frame on a port and it will receive another frame on that port before the time limit expires, then it will update the timer counter for that interface. Okay, and here I believe you can still mention the ARP, the Address Resolution Protocol, because as I said, we are at layer 2, and the Address Resolution Protocol means that the device has a particular IP address, but as I said, we are not talking about IP here because we are only at layer 2. Then the switch will flood out the the ARP message on all ports to all devices or all destinations or hosts, and the host that will check and will see that it's his or her IP will simply send back its MAC address in order to make this transmission possible. Okay, flow control examples. So about flow control, what the flow control means that there is a receiver, or I'm going to visualize it. There is let's say that this is the receiver. No, yeah, this is the receiver and the purple will be transmitter, and that simply means that the transmitter will send data to the receiver, and the flow control means that how much data the receiver can receive at a time. So for example, just imagine that this is a simple traffic, but for example, imagine that we will send more and more and more, then the receiver will, okay, then the receiver will not be able here to receive all. So for example, it will receive a certain amount and then it will drop. So the flow control is really important, that this should be somehow managed in a way that the devices can, how much data can share between each other or exchange. For example, the TCP does this resource handling during the TCP handshake, because during the handshake the TCP will check that how much resource can send to the destination at a time, therefore it will not send more. So that's the flow control, and this was, for example, an example. So the detection and correction mechanism of transmission errors, as I said, I already talked about this, so I'm not going to mention here. Of course, the parity bit is the simplest one, and that's the one I thought about. But of course, there are more approaches. But the parity bit, I believe, uses enough time, so you don't have to talk about other